Welcome you all. Today we are going to discuss one more problem in a fuels and combustion. It states that in a fuel-rich combustion product mixture, equilibrium between the species CO2, H2O, CO and H2 is often assumed to be sole determinant of the burned gas composition. If methane is burned in air with an equal ratio of 1.25, determine the mole fraction of the products at 1800 Kelvin. Comment any other likely dissociation reaction, whether or not this is likely to be significant and whether it is reasonable to assume equilibrium condition. They are asking, given methane CH4 burned with the air equivalent ratio of 1.25. Then the equilibrium between the species CO2, H2O, CO and H2 is the sole determinant of the combustion products. Find out the mole fraction of the products at 1800 Kelvin. We know that CH4 methane, when you write an equation for this burning of CH4 plus Y O2 plus 3.76 N2, it will give for complete combustion ACO2 BH2O plus CN2. We have to find out what is Y. This Y is equal to, I given a formula for a hydrocarbon fuel, CaHbNCOD, A plus B by 4 minus D by 2. Y is equal to 1 plus 4 by 4 is equal to 2. Stoichiometric air fuel ratio is equal to 2. Equivalent ratio is equal to 1.5. It is the ratio of stoichiometric air fuel ratio over the actual air fuel. We can find the actual air fuel ratio 2 divided by 1.25, that is equal to 1.6. Now we can write the combustion equation with the air requirement is 1.6 CH4 plus 1.6 O2 plus 3.76 N2 gives ACO2, because this one is given ACO2 BCO CH2O DH2 is given. These are the sole determinant of the combustion product they given. And one more thing, this nitrogen is this 1.6 multiplied by 3.76, that is equal to 6.016 N2. Now we will go for carbon balance. In the left side carbon is equal to 1, in the right side A plus B. We can write an equation B is equal to 1 minus A and another one is A is equal to 1 minus B. Next we will go for oxygen balance. Oxygen balance here 2 into 1.6 is equal to 2A plus B plus C. We can write this one 3.2 is equal to 2A plus B is equal to 1 minus A. 1 minus A plus C. We can derive it 3.2 is equal to A plus 1 plus C. A plus C is equal to 2.2 or A is equal to 2.2 minus C. Then we will go for hydrogen balance. 4 hydrogen is equal to this side 2C plus 2D. Then 2 is equal to C plus D. Already we know that the relationship between these two. Then B is equal to 2 minus C. We can write this one in terms of B. A is equal to 1 minus B is equal to 2.2 minus C. Then B is equal to C minus 1.2. Now they given equilibrium between species. What are the equilibrium they given? CO2, CO, H2O, H2. Now we will go for reaction number 1, 2, 3, 4, 5, 6, 7 is that. Which one is covering these 4? Number 7. What it is called a water gas shift reaction. We can write this number 7 as CO2 plus H2 gives CO plus H2O. Both sides reaction happen. Now reaction number 7 at 1800 say Kelvin, ln Kp is equal to minus 1.330. Then Kp is equal to e power minus 1.33 is equal to 0.26447. We can write this one 0.2645. What is Kp? We know that P dash of CO2, P dash of H2 over P dash of CO, P dash of H2O is equal to 0.2645. So these components are unity and the pressure is not given in the sequence. Put it A here, B here, C here, D here. We can write CO2 in terms of A, H2, D, then CO, B, H2O, C. You can put it here, A, B, then C, D. So AD by BC is equal to 0.2645. Then A multiplied by D is equal to 0.2645 multiplied by BC. Now we know that the relation between A and C 2.2 minus C, then D and C 2 minus C is equal to 0.2645. Then B and C minus 1.2 multiplied by C. Then next simplification 2.2 into 2 4.4 minus 2.2 C, then minus 2C plus C square is equal to 0.2645 c square minus multiplication of this one 0.2645 into 1.2 0.3174 c. Upon simplification we can get 0.7355 c square minus 3.8826 c plus 4.4 equal to 0. Then when you are making c square terms as 1, c square minus 5.278 c plus 5.9823 is equal to 0. Simplifying this quadratic equation, c is equal to minus b plus or minus root of b square minus 4ac by 2a. c is equal to either 3.6299 or 1.648. Now oxygen balance, a plus c is equal to 2.2. A is mole of carbon dioxide, a is the CO2 and c is H2O. This a should be greater than 0, then the CO2 will be present. Therefore a is greater than 0 means c should be less than 2.2. Therefore c value is equal to 1.648. Now when you are finding out the other parameters, a equal to 2.2 minus 1.648, that is equal to 0.552. Then b is equal to 1.648 minus 1.2 is equal to 0.448. b is equal to 2 minus 1.648 is equal to 0.352. Now for checking this one, a multiplied by b, b multiplied by c is equal to 0.2632. What is our value? Is 0.2645. This is close to our value. So the combustion equation becomes CH4 plus 1.6 O2 plus 3.76 N2 gives 0.552 CO2 plus 0.448 CO plus 1.648 H2O plus 0.352 H2 plus 6.016 N2. Now the summation of the product is equal to 9.01. So the percentage of CO2 is equal to N of CO divided by summation of the product is equal to 0.552 over 9.016. 0.06122 is equal to 6.122%. Percentage of CO is equal to 0.448 over this one 4.968%. Percentage of H2O 1.648 over 9.016 18.27%. Then 0.352 over 3.904%. Then this percentage is equal to 0.016 66.72%. So this is the answer.
Subscribe to our channel, like if you're satisfied, and share because it may useful to someone.